Today's lecture is fifth about making semiconductor. I call this lecture that how oxide the vapor oxidation that have positive and negative for performance and show you formula which makes oxidation. First, when we make local oxidation of silicon, this course name is locus. And this is negative, so these days we use not this method. Because this method occurred to very big, that is phenomenon, which SiO2 swells and both ends of silicon nitride are climbed, so the solution is to make the etch in advance isotropical, making it less polluted. These days, people use DTI, deep trench isolation, or STI, shallow trench isolation instead. This means that the trench is pre-cut with the area and the polysilicon is put in here and is completely isolated. When we oxide this vapor, we make surface planarization, because aligning the metal layers cross out each other is occur pinch work or overlay. So, using the slurry for chemical mechanical plusing, this course CMP. Summer oxidation is similar to etch. Oxidation is divided in wet and dry. Wet is fast and cheap, but hardly controlled. On the other hand, dry is slow and expensive, but easy to control. Ordinarily, we use SiO2, which is amorphous solid, and using for gate dielectric, locus, STI, and ILD. Thermal oxidation is excellent electrical insulator, high breakdown electric field, stable and reproducible Si and SiO2, conformal oxide growth on silicon surface, and have some positive things. Process is place the vapors in a large container and use the controller to make the oxide. Only the middle one is used for reasons such as temperature differences. The process is also similar to etching, in which the gas is diffused due to the difference in concentration and is attached to the surface to form a solid state diffusion, resulting in oxidant diffusion forming SiO2.